I was first asked to make this presentation. I was asked to make it advanced. It was supposed to be advanced soil biology. And then I noticed they put intermediate.
Okay, so the world's largest mining operation is ran by fungi. And it's really an interesting statement when you begin to think about that. But in the images you see here on the right is fungal. I think that's actually a root system. This is taken with a camera. There's no fancy equipment on the right there. On the left, that's a microscopic image. But on the right, it's a camera image of, and you see some straw and some soil and things, and you see the roots there, and that looks like what is infested or infected. Well, I wouldn't like to use the word infected, but that gives it a negative connotation. It's not really negative, but that's mycorrhizae on those roots. If you see that, the best place to find mycorrhizae, somebody asked, where can I find mycorrhizae? And they're looking for it commercially in a package. We mentioned that one place, but next to that, a forest. You go to the forest floor and you look for white stuff like that. You pick it up and you go take it to your garden, and that's essentially mycorrhizae. What species is in there? I don't know. There's probably several thousand species or several hundreds of spores and everything else inside of there. So what you're going to get, I don't know, but what's going to survive is species that are going to tolerate your soil environment. On the left, we see an image of I don't remember what this was. I want to say it was gibbsite or mica or some other type of mineral. But either way, you see those holes, and it kind of look like worms or lines in the center. And what that is that this is a piece of rock. You're looking at it in a microscope, so it's it's not a big rock like you see outside that you pick up and maybe you'd want to throw, but this nonetheless is a mineral rock, very small, microscopic, and those darker colorings that you see on there is where fungal hyphae have weathered away at some of this rock. Here's another image. This is an electron microscope. So these images that I'm going to show you right now came from, they were actually taken not even a year ago. I want to say that it was February, March of 2017. And this is some of the first imagery to be taken of fungal hyphae and the weathering of basalt and a couple other minerals that was collected in the Catalina Mountains in southern Arizona, just outside of Tucson, an area where I'm from, which made me fall in love with it even more. I liked the image just by itself, and then when I was told where it came from, then I really got excited. That was near my hometown. But anyhow, here's a fungal hyphae. That's how tiny these things are. And I want to say that white bar on the bottom right corner symbolizes 5 micrometers. I'm sorry, 5 micrometers or micrometers, I want to say is what it was. And so this is really, really tiny. I mean, you're looking at this, again, with electron microscope, and we're seeing these things, and this is a web of fungal hyphae around a piece of basalt. We look at this image, and what you see, you can hardly see it. Maybe the folks in the back can't see it, but you see something that looks like a worm or something like that, kind of going around the bottom here and making its way to the top. That's another a weathering of basalt. And I think in this particular example, that's actually, fungus is actually after potassium. It isn't phosphorus, but it'll actually get phosphorus the same way. And this is where a lot of the weathering comes from your parent material, your rock that is in your soil, especially in the mountainous regions or anywhere where you have a lot of rock, which really, I'm going to throw this one in there. I wasn't going to talk about it at first, so I don't have a whole bunch of the slides, but Ellen White talked about soils, and she was shown by essentially Jesus what soil would be productive and what ways to plant fruit trees. And a lot of people ask, how is it that this is, where's the science behind this, essentially? And the sad thing is that, and it blows me away so much, but one of the sciences that is essentially really behind the curve, and for a lot of reasons, and some of it is research, and some of it is lack of people that are interested in these things, but nonetheless, soil science is one of the sciences that is really just I mean, way behind the curve when it comes to making discoveries. We just, as a human race, we haven't really put in the effort we need to put in to figure out what's going on in that soil. So here we are in 2017, well over 100 years since Ellen White suggested where things ought to be planted and how they ought to be planted based upon visions that she was shown. And we are now still not even sure how that works. But I have a hunch from the wisdom the Lord has given me to the understanding of soil biology as to what's going on in there. And I'll talk about that in the other session I have tomorrow on titled "What is Soil?" I encourage you to come to that if you would like to know how I make those connections. But here's another image. Same thing. What you see coming up to the side here is a fungal hyphae, and this is the scale of 30 micrometers. From one side of the screen to the other side of the screen is 30 micrometers. That's very tiny. And that's weathering of a piece of basalt there. Here's another image, the same thing, very similar. This time it's 50 micrometers is the field view from one side to the other. But you see, again, weathering in these rocks. You see weathering over here in the, or actually, I think that's actually, that is a weathering of that soil there, that piece of basalt. I'm sorry, that mineral. Here's some more images. This is the kind of milky looking like stuff that you see wrapping this piece of mineral here is the fungal hyphae. Wrapping itself around these things and making itself or extracting the nutrients that are in there through different exudates that it sends out. And this was really exciting because a lot of these types of images had not ever been captured before. And how this was done is that they took litter bags that, I don't remember the mesh of these litter bags, but they were really tiny. And they put some basalt in it, they put some inoculants in it, or actually I don't think they put any inoculants in it. They just put the basalt inside of these weathered bags, or inside of these soil bags, they buried them, and then they came back a year later, pulled them out. And then they took them into the laboratory and they started just shooting a whole bunch of images of what they found. And this was really exciting because it was for the first time for the soil science community where we had seen images and proof of how fungal hyphae can actually weather minerals. They had always believed that that's nothing new, but they just didn't have the images to support it. Again, here's another fungal hyphae coming out the side here, and you're looking at really tiny images here. This time I forget, the scale keeps changing. This is 12.8 micrometers. Very, very small, but you can make it out coming here. It goes down and it wraps its way around there, and this was basalt, so it was really after potassium. And you have to understand the mineral makeup of these minerals in order to understand what nutrients the fungus is after. And there's a lot of different minerals, especially we start getting into granite and other things where you have phosphorus, you have potassium, you have magnesium, you have calcium. I mean, all these different things, all these names that I'm throwing at you, like basalt, they all signify something and mean something in the soil community. So when you think about limestone, we think about lime, but really it's just natural formations of calcium and magnesium carbonate. When you think of dolomite, that's same thing. It's a limestone, but it's a high magnesium limestone. That's where we get dolomitic lime, the name anyhow. So this is where these names come from. Here's another image, similar thing. You've got some more hyphae coming out of the side. Show you another one. So this is actually one where we have hyphae coming around the corner, and they even started finding some critters that they weren't even sure what it was. And it was amazing because they were looking at things that looked like some type of microbiological, multicellular biological life that they've never even heard of. So it's interesting what happens when you just take technology like that and you start taking pictures of things in the soil and what you'll come up with. All right, so that wraps up the mycorrhizae and the phosphorus for us. We're going to get into the sulfur cycle now. So this is one that I was hoping we would get time to talk about. Oh boy, I didn't keep track of time. We're supposed to have 5:15. Okay. All right, so the sulfur cycle is a lot like the nitrogen cycle in that there is a lot of different oxidation states of sulfur. And one of the biggest things with sulfur, we know also that there's a lot of different microorganisms that can move sulfur around and change it around to whatever it is that they prefer. And sulfur is oftentimes used in the soil for acidifying, especially your alkalinic soils in the West will get applications of elemental sulfur to acidify the soil. How does that work, and why you should do that or you should not do that? You have to understand the redox potential and how these organisms will essentially take these elements and pull hydroxides out of the soil, leaving hydrogen behind. So they're using water, and eventually that's what actually produces the hydrogen and the the decrease in the pH and the increase in the acid of the soil. I want to share with you different images of the sulfur cycle. Here's another image. Actually, I should have probably shared a couple of things more. I like this one because it's more colorful. It's usually easy for people to see things with color, but I wanted to add some other ones that didn't have color, and this is similar to the other image where we're looking at the components of atmospheric sulfur, which can come down in sulfur gas. It can also come down in acid rain if you live in an environment with a lot of manufacturing or burning of different things. It's not as bad as it used to be since they implemented different coal burning technologies, but used to be that you had an awful lot of acid rain in certain parts of the country, and what that was really bringing down was sulfuric acid and through the rain. So that's one method that you can get sulfur additions into the soil. It can volatilize like nitrogen, form into a gas. It can leach through the soil. It will leach. Sulfur is something that will definitely, or sulfate particularly, will definitely move through the soil without any delay. If that soil is sandy or somehow it can move moisture, it's water